So let's start with the STAAR pipeline for GWAS. So let me pull up some notes. So this is new for me. I've never done a tutorial on this before. So bear with me. But it just came out for body to catalyst powered by 7 bridges. It was also available on Terra, which I'll get into. STAAR pipeline stands for Single Trait Association Analysis with Relatedness Pipeline. So it's a new application designed to analyze whole genome or whole exome data, and it provides a really accurate representation of genetic data by accounting for relatedness within the samples, like some other pipelines do as well. And of course, it's great because it provides great association results and reduce false positives. So it's based on an R package. Great question, Prithvi. So I see it's coming in. So how was the relatedness calculated? So I don't know the answer to that. I'll have to get back to you. I think I'm assuming that you can use the same, like if you're going to use this on TopMed, I'm assuming that you would use the same relatedness matrices and PCA, but I don't know. Good question. So the package in particular includes 2 key features. So you can analyze single variants or what they call variant set analysis. So the single variant analysis gives us the capability to evaluate individual variants and get p-values based on things like minor allele frequency, of course, and minor allele cutoff frequency as well as other things. So going on, so if we dive deeper into what they call the variant set analysis, it consists of gene-centric versus non-gene-centric analysis of rare variants. Gene-centric coding analysis offers several genetic categories: putative loss, function missense, disruptive missense, combination of putative loss of function and disruptive missense and synonymous. On the other hand, you can run gene-centric non-coding analysis, which provides even more categories. Thank you, Kritika. So this is the kind of collaborative stuff I want to encourage at our community hours and at other events too. So for non-centric gene-centric analysis, the STAAR pipeline includes features like sliding window, analysis with fixed sizes or dynamic sizes. It also has in-depth analytical follow-up of really dissecting the association signals independent of known variants, and that's through the feature called the STAAR pipeline summary. So that was the overview, and of course, use cases. Everyone knows this. This is right in our wheelhouse. These are widely used in genomics and medicine. Genotype, phenotype solutions are popular, and STAAR is becoming more and more popular. And I think it's unique because it has a unique way of enabling the single variant and the variant set analysis features. Okay, so how was it implemented on BDC? So the initial description was in the workflow description language, which of course works well on BD Catalyst powered by Terra. So it was published in 2022. And actually the lead author is Dr. Gaynor, who was a BDC fellow at cohort 1, and I see Kenny Westerman as well. Anyone else? Who also was a fellow cohort 1. And this is a sort of a picture from their publication here. So, it's the same general procedure. You fit a null model, then you run what's called RV tests, and then you compile your results. What's new is the common workflow language description on 7 bridges, which runs very well on BD Catalyst powered by 7 bridges. So that's new. So what else do we have? So how would you use this? So you can copy apps from the public. It's in the public apps gallery. So here's the link. bit.ly.bdc.-apps. I always like to promote this link in particular because we don't actually have to log in. So why don't I go take a look over here? So as you can see, I'm not actually logged in. So this is publicly available to anyone on the platform. So anyone on the internet, essentially, you don't have to log in. So these are all the CWL apps. In this case, it's really easy just to search for STAAR. And what I want to call out is that, so there's multiple tools here. The main one is the STAAR pipeline, and you have a couple things I want to call out. You have the pipeline version. So as soon as a new version is released, this will get updated. And you have something, this is new, and this is really in my wheelhouse in particular. There's an effort to get these apps more portable. And so there's something called the CWL tool, which is a reference runner for the CWL tool specification. So you can actually run this pipeline anywhere that you can install CWL tool. So if you want to work on your local laptop or local HPC, you can run this description of the STAAR pipeline, as long as it has this tag here, CWL tool tested. So this is the main one. The other ones come into play as well. Something else about the CWL specification is that all this information is it's like a sort of self-describing file. So all this information about how to run the pipeline, to run the tool is here. And what's interesting here is you would run this multiple times. So as you know, in Genesis, there's a separate tool for the null model. Here, you're going to run this once to fit the null model. And then here are the requirements for the null model. So there's a question about the kinship. So it's sparse, of course. Kritika, you have a question. Go ahead.
Hi, David. Yeah, I have a quick question. I realized that you have to run a different null model. So does that mean the one that we have from Genesis is not compatible with STAAR here?
Great question. I'm not sure. I haven't had time to dive deeply into this, but I think we should check that out. I think we should meet and try to run it.
Okay.
But I'm not sure.
I got that question mark down, and let's find out, and we can follow.
Okay. Yeah, I'm just specifically about the CWL wrapper around it. Instead of being like a workflow with multiple apps, you would run this once for the null model, get the results, and then run it again to do your association. So it is, I mean, the null model for Genesis is absolutely in our object. But yeah, I'm not sure. That'd be good to test. So it has common use cases, some important notes, and then of course performance benchmarking. So if you're if you want to know how much this would cost to run, I think these values and these prices are pretty good, because for instance, if we want to use even the largest chromosome 1, 61,000 subjects, I mean, it's coming in at $14, I think. Yeah. Which I think is pretty reasonable for that level of subjects, for that number of subjects, and also the hour. It's only running in 2 hours. So of course, you know, if you're testing, just use chromosome 22 or something like that, and it'll finish even faster and be much cheaper. So you'll see. Okay, so this is the general procedure to do the testing with chromosome 1, 10, and 21. So it's only 33 minutes for chromosome 21 for 61,000 subjects. That's of course the single variant test type, but there's several other types. So it's a really complex package, all in this one sort of object here, the STAAR pipeline. Okay. Any other questions about STAAR before we move on to Metacyto?
From where you have shown the documentation, can you please say it again and show it again?
Sure. This one?
Yeah, this one.
Okay. Yeah, it's actually, I'll zoom out here. It's right here. So here, I'll put it in the chat. Everyone click on that. It'll open, should open right up. No login required. And by the way, if you ever, well, so there's more links here, source code, homepage, some deeper documentation as well. Hi, Kritika. Is your hand up again, or was that from before?
Yes, it's up again. So I have another question. I know you showed us the main STAAR pipeline. What are the other STAAR apps that you have in there? I mean, I was wondering if this is at all something that can be used on structural variants too. I mean, I did see something in GWAS, so I wasn't sure what that was. The second one here, STAAR pipeline.
Yeah, I'm not
yeah.
sure. That's another great question. I didn't do enough homework to understand what this tool is actually doing. I don't think it can handle. I think it's mostly genotypes and phenotypes with annotations.
Okay.
So I don't think it. My understanding is I don't think it handles any other types of variant information outside of genotypes and the annotation.
Okay. And this is available already for use, right? The
Yep.
first analysis pipeline of that is okay.
Yeah.
The
So all
first
those.
app.
Yeah, all those apps are. All these apps are available to
Okay,
use.
perfect.
And
Perfect.
this annotator is how you would create, I think what they're calling a special GDS format, which has the annotation. So it's some things very similar to the Genesis workflow, but there's
Yeah.
enough of a difference to. I would go slow, and we should probably develop some more learning materials around how to use this.
I would be more than interested in seeing, like, because you also have GDS file formats that are required for Genesis, and also your GRMs and what do you say, what was the first one? Yeah, the null model and all of that. If they are compatible, so you don't have to do two of those to run STAAR and to run Genesis. So that would be of immense help if we could get some clarity.
That's a fantastic question. And by the way, Kritika, so something that was, I know you wanted to see a demonstration of Annotation Explorer, which is entirely based in entirely for Genesis. It wasn't working, so I'll just say it's all working now. There was an issue with public projects, cloning of public projects, all completely fixed now. So we can definitely meet, and I can show you a demo of Annotation Explorer.
Perfect.